Hello and welcome to this video on equations and solutions to equations. We're going to start here on page 88, starting a new section today. Last topic we talked about expressions. And remember, expressions were just a number or a group of numbers with operations in between them. So for example, 4 is an expression. 2 plus 2 is an expression. And it doesn't just mean I just do addition. I can do division, subtraction, and so on. I remember when we were doing order of operations, we were working with expressions. You know, that's going to change today, all right? But first, it said to write different expressions that equal 4. So these are some of the examples students gave me. They said 8 divided by 2 would be 4, which is true. 2 times 2 would be 4. 1 plus 1 plus 1 plus 1 would all be 4, or 2 plus 2. They all equal 4. Okay? Then it said write a different expression that equals 4 plus 5. So here's a little bit different. We need this side to have a value that's the same as this side. So 4 plus 5 is 9, so we need something that gives us 9. 3 times 3 does. So 3 times 3 is equal to 4 plus 5. Same as 6 plus 3 and 18 divided by 2. 4 plus 5 would also be equal to 10 minus 1. So those are just some examples. Obviously, there's an infinite number of possibilities here. Okay, so with that, let's go and take a look at the word equation. Equation is a statement of equality between two expressions. Now, the way I say it is, an equation is two expressions that are equal. Okay, think of an expression like a phrase, equations like a complete sentence. It takes several phrases, puts it together for a complete thought. All right, and the key is it has an equal sign. All right, for it to be an equation. If it doesn't have an equal sign, it is not an equation, it's an expression. Okay, but an equation is made up of two expressions. All right, and then along those lines, equations can come in many forms. Okay, so we kind of jumped here to page 92. Okay, so because expressions are either numeric or algebraic, and again, review, algebraic means there's at least one variable. Okay, so if it's algebraic, it has a variable in it. So let's look at some of these equations. So equations are statements that may be always true, never true, or true for only one or more values of the variable. Okay, another way of looking at that is if it's always true, they have infinite number of solutions. Okay, if they're never true, that means there is no possible solution or no solution. Nothing can we put in there to make it true. And then true for only one or more values. So that would most likely be one solution. Now there's some times where it might be 2 solutions or 3, but usually if there's any solution, it's 1 or infinite. All right, so let's look at some examples. If it's always true, 6 equals 10 minus 4. Okay, that is always going to be true. Because 10 minus 4 is 6. 6 is equal to 6. X equals X. That is always going to be true. Because anything we put in for X, let's say we substitute 3 for X, 3 will have to be equal to 3. You can't change the value of the variable inside of an equation. Okay, I know variable means to vary, but it will never vary inside of an equation. Okay, so if it's 3 on this side, it's got to be 3 on this side. If it's 10 on this side, it'll be 10 on this side. All right, never true. Like, for example, 10 equals 20. That will never be true. Doesn't work. X equals X plus 2. Okay, think about it. If I put something in for X, let's say 5, for example. 5 will equal 5 plus 2. Well, 5 plus 2 is 7, not 5. So it doesn't work. Okay, so I can't put 5 in for X and make that a true statement. All right? Now, sometimes true for certain values or one solution, X could be 5 and this would be a true statement, right? But it's not true for everything, because if I put in as 8, it would not be true. So it's true for one value. All right? Same thing here. X plus 2 equals 12. If I make that a 10, then I've got a true statement, because 10 plus 2 would equal 12. All right. So down here, I kind of modified a little bit. I gave some equations here. So m times 2 equals 2 times n. And then n times 2 equals n. X plus 1 equals 9. I asked you, is it one solution, no solution, or infinite solutions? Okay, and in this first one, we decided it would be infinite. Because if I put a 4 here, 4 times 2 would be 8. And then remember, it would have to be a 4 over here. So 2 times 4 would also be 8. Okay, and I could do that with a 5. I could do that with 100. I could do that with a half. There are all kinds of possible solutions. They're infinite. And number 2 has one solution. Now, it doesn't look like it has a solution, because if I put a 5 here, 5 times 2 is 10, which is not equal 5. But actually, it's kind of a trick question. If I put 0 in here, 0 times 2 is 0. and that equals 0. Okay, 3. X plus 1 equals 9. Okay, what is x? Well, x could be 8 and make that a true statement, but that's the only value that would make that true. So it has one solution. All right, last page. Okay, over here, this is starting to look a little bit like our assignment on page 93. A solution to an equation is a value for a variable that makes the equation true. So it makes the statement true. That's the key word here. If I put that number in for the variable, it will be a true statement. So here I'm asked to look at this set of values, okay, just a list. That's what these braces mean. That's a list. And I need to figure out which one of these makes it true. So 1 would not make this true because 1 plus 3 does not equal 7. 2 does not make it true because 2 plus 3 is 5, not 7. 3 plus 3 is 6, which is not 7. But 4 works. 4 plus 3 equals 7. So my solution to this is 4. It's the only one that's possible. X equals 4. Okay? So again, which one of these makes it true? This one does. Now on B, 1 would not make it true because 2 times 1 does not equal 10. 3 would not work because 2 times 3 equals 6, not 10. 5 would work. 2 times 5 is 10, which is that. 7 would not work because 2 times 7 is not 10. And 9, so there's only one solution, and it should be 5. All right? So your assignment's going to look a lot like this page or the one before. All right? It's that worksheet. All right? Thanks for watching. Bye.